Hi friends, today I am going to explain about has-a relationship in Java. The has-a relationship represents composition or aggregation in object-oriented programming in Java. Composition means strong relationship between two classes, whereas aggregation means weak relationship between two classes. Instead of inheriting properties from a parent class like in is-a relationship, in has-a relationship, one class contains a reference to another class as its member. For example, if there are two classes like A and B, class B holding a reference of class A as its member. So the reference of class A is present inside class B. This promotes loose coupling and core reusability while maintaining better control over object relationships. For example, a car has a engine. Here, engine class is present inside a car. That is, car is holding the reference of engine class. And a person has a bank account. Here, a person is holding the reference of bank account. So, bank account is present inside a person class. Let's see an example. We'll see here example of engine and car. We'll see in VS Code. Let's create a main.java file, and in this file we create a engine class. This is a class engine. Inside we write a method, start method, and print statement system.out.println engine is starting. And we'll take another class. We have taken engine, then we take car class. Inside the car class we have to hold the reference of engine. So we have to create the engine. So here we take private variable engine of type engine class, and we'll initialize this engine class inside a constructor. So whenever we initialize the object of a car, then engine automatically initialized. And we'll take a method void drive method. Inside drive method we'll start a engine.start method. Start method is present in engine class, and we'll write a print statement car is driving. So here I have taken a engine class and I have taken a car class, and inside the car class engine is being created. So one class is present inside the another class. Here car has a engine. This is what we call as has a relationship. Here car class is holding the reference of engine. So here we are creating has a relationship between car and engine. It's not is a relationship. It's not car is a engine or engine is a car. It is car has a engine. Engine is present inside a car. So this is how has a relationship demonstrates in Java. And we'll take a main method inside the main class and create a car object and car.drive. Whenever we start, whenever we instantiate the car, that is we creation of object. So at the time of creation of object, engine is being started. That is the initialization of engine is being happened inside the car class constructor. So whenever we created an object, the engine is being initialized, and whenever we call the drive method, engine has been started. So the engine class is present inside a car class, and if we compile the code, it compiles fine. And if we run the code, we should print whenever we call the drive method, it goes to a drive and it again calls the start method which is present inside the engine class. So engine is starting and car is driving is the output. So whenever I run the code, engine is starting, car is driving is the output. So here, this is what we call has a relationship. Has a relationship in the sense one class is present inside the another class. That is, a class is holding the reference of another class. Here, car is holding the reference of engine class. And this is an example which we have discussed. And let's see what is composition. Composition means strong has a relationship. Composition is a strong form of has a relationship in object-oriented programming where the contained object cannot exist independently without the container object. Here there is two objects. One is container object and one is contained object. Without existing of container object, there is no existence for contained object. For example, if you see the university and inside the university there is one branch, that is, let's say, computer science branch. So here university is a container object and computer science branch is a contained object. So without existing the university, there is no existence of computer science branch. That is, here university and computer science branch is strongly related. So without existing the university, there is no existence for computer science branch. This is how composition demonstrates in object-oriented programming. So it says that where the contained object cannot exist independently without the container object. Only when the container object is existed, then only contained object is existed. When the container object is destroyed, when the university is closed, then automatically inside all the branches are being closed, like computer science branch is being closed. So without existing the container object, there is no existence for contained object. So these two are strongly related. If the container object is destroyed, the container object also gets destroyed. This represents a strong association between the objects, ensuring ownership and lifecycle dependency. Let's see the real-time examples. Some other real-time examples. A human has a heart. So heart have no existence without human. So a laptop has a processor. A process is an integral part of a laptop. If the laptop is discarded, the process becomes useless. So this is how composition works in object-oriented programming language. So let's see what is aggregation. Aggregation means weak has a relationship. So aggregation is a weaker form of has a relationship in object-oriented programming where the contained object can exist independently of the container object. Let's see the same example here. We'll see computer science branch and professor inside a computer science branch. So here computer science branch and professor have a weak relationship. If if in a university computer science branch is closed, if there is no computer science branch, then a professor can work in another branch also. He can work in mechanical branch or he can work in civil branch or any other branch. So here a professor and a branch has weak relationship. So if a mathematics professor can teach in computer science branch, he can also teach in mechanical branch. So here a mathematical professor and computer science branch has a weak relation. So without existing of computer science branch also, The professor can exist. He can teach in another branches also. Like this, it is a real-time example. Like this, aggregation works. It is a weak has a relationship. If the container object is destroyed, here if the computer science branch is destroyed, the container object still exists. Here professor still exists and can be associated with other objects. Like he can teach in other branches also, in mechanical branch or in other branches. So this represents a weak association allowing greater flexibility and reusability of objects. So without existing container object also, contained object can flexibly move from anywhere. So let's see real-time examples. A university has a professor, as we discussed. A team has a player. If the team is destroyed, a player can work in another team. He can work in any team. So here team and player has a weak relation. Although team has discarded, a player can go and play in another teams. A company has an employee. Yeah, here employee and company relationship also weak. A employee can work in any other company also. If this company is closed, then a employee can go and work in other companies also. So employee is fully independent of company. So employee and company has a weak relationship. This is what we call aggregation. Let's see an exercise. Please pause the video and answer the questions. First question. Which of the following statements best describes a has a relationship in object-oriented programming? It is a type of inheritance where one class extends another. No. It enforces tight coupling between classes. No, it's loose coupling. It is used only when both objects must exist independently. No. It represents a relationship where one class contains a reference of another class. Option D is correct. It's the second question. Which of the following statements is true about aggregation? Aggregation means weak relationship. So without existing container object, also contained object can exist independently. So option A, the contained object cannot exist without the container object. No. Aggregation enforces strong ownership. No, it's a weak. If the container object is destroyed, the contained object still exists independently. Yeah. Option C is correct. Third question. Which of the following best describes composition in object-oriented programming? It is a weak form of has a relationship where objects are loosely connected. No, it's a strong relation. It is a strong form of has a relationship where the contained object cannot exist independently of the container object. Option B is correct option. Thank you. Please like, share and subscribe for more videos.